All in well, just fine. Kind of go over calendar again, because things are kind of happening pretty quick right now. Here we are on the 20th. 4, 3, 4, 4, 4, 5 are due this Sunday. That is a hopeful midterm review. Okay. Hopeful. I want to do a midterm review. Because your midterm will be right here on the pool. Okay, same way as we did before. You do it on your computer, turn in your scratch paper, just like that. And of course, don't forget, no class on the 6th. Okay, I will be sending out an announcement that previous Sunday, I'll be going to a conference. But just to show you, there is a review that you can start looking over. Okay, so if you come over here and go into your modules, come all the way down to midterm, look at midterm right here. Ooh, I don't think I have it posted for you. I will get it in there today. Oh, let me hold on. Wrong thing. Look right above it. Midterm review PDF. Really, I put that down there. Forget a lot of things, but I wouldn't do them. Notice, this is almost every type of possible question you could get on your midterm right here. Okay, every single one of them. Of course, don't memorize it because I changed the numbers. Okay, so I've had people try to memorize the numbers, and I'm like, hard as it is to memorize the numbers, it's easier just to learn how to do the test. Okay, so that's there to work. Every single question, just to be honest, every single question I pull from your midterm comes directly from your homework. Every one of them. Okay, so if you're doing okay on the homework and you're just fine, you're going to do just fine on the midterm. I guarantee you. Okay, if you're skipping through the homework, using your phone, using a friend or whatever, midterm is going to be pretty hard. Okay, just kind of being honest about that. So kind of look at that. Some of the questions are going to be straightforward and simple. Like, I believe the key terms ones, they're multiple choice. Okay. Can you identify types of graphs? I give you the types of graphs. Can you identify all of those? Which one's skewed to the left, skewed to the right? Okay, symmetrical and uniform. Do you know what all those mean right there? Mean, median, mode, all that kind of stuff. Could you do all that? Range, variance, standard deviation. Being real careful to realize that right there. There is a difference, isn't there? Okay. Measures of relative position. Can you calculate the first, second, and third quartile? Which, to be honest, what are you going to do? Put everything where? In your calculator, and it does it for you, right? Okay. Saw a lot of weird answers. I'm going to be honest with you. On that was an area that people were lacking a lot on your percentile and imperial. Okay, that was the area people missed the most on. Okay. Cumulative frequency. Okay, no, it's pretty straightforward, right? I show you now. This one's a little bit misleading because I'm showing you Chebyshev's theorem. On your midterm, I don't give you the theorem. Okay, so you don't get to see the formula. But if you remember, doesn't the formula, what is it exactly the same thing as? Think about it. Last letter in the alphabet. Z-score. It's the exact same formula as the Z-score when you really look at it. Okay, so if you know the Z-score, you know Chebyshev's theorem. The hardest part about Chebyshev's theorem is, look, you got to know, hey, if it's a 2, it's 75%. If it's 3, it's 88.9. Okay, that's kind of the hardest part. And good news, I do tell you to use that theorem. Okay, it's not like, when do I use it? Okay, I'm going to tell you, using this theorem, tell me this. Okay. Manufacturer, that's once again, you're looking at the Z-score. Pretty straightforward there. Here we're into probabilities. Probabilities. Just learn that, you just learn that. And then pretty much the ones after this one, we'll get into. All this right here, after this is going to be a lot of, that one's actually, when you actually look at it, it's gonna be pretty straightforward. Not a lot from 5.1 and 5.2. I think there's only like one question between 5.1 and 5.2, but there is a specific thing you need to look for, which I'll show you. Okay, we good? But I mean, that's your midterm right there. Okay, so, what I will do on the midterm review, if we have time, like I said, 5.1 takes a little bit longer. We might be able to finish in this class, might not, okay? 5.2 is pretty straightforward. There's some tricks to 5.1 that I'm gonna show you on your calculator. Because if not, you get this really gnarly looking like graph looking thing, table you gotta fill out completely and do all these massive amounts of calculations. And it just gets really annoying really, really fast. Or once again, put everything in your calculator, but it's kind of a more multi-step process in your calculator to do it correctly, okay? And the only problem I have with multi-step means a lot of more moving parts. And so it's one of those, really make sure you're putting all your data into your calculator correctly, okay? Because it's one of those things where if you put in one wrong number, the problem actually kind of compounds wrong on itself. So it actually become more wrong, okay? So you'll see very shortly. What I would suggest doing, okay, because this is a pretty long review, you're gonna need to email me what you want me to work. Okay, I'm not gonna stand up here in front of the class, but okay, what do you want me to work? And we just kind of just play the numbers game. Okay, I need you to email and go, hey, you know what, I'm having trouble with this, and would you show me how to work it? And then I'll just kind of pull from that list whenever we come and do the review. So that way I can kind of show them, okay? I'm kind of gonna do like my old I think I told y'all, my old Cal 2, Cal 3 professor used to come in and go, okay, what do you guys want to review? And if none of us raised our hand, like, all right, class is over with, good luck on your midterm, and he'd just walk out. Okay, I don't want to do that, so I'm giving you a chance to kind of, I get it, probably gets a little like unnerving to raise your hand and go, will you work this one? Because then you feel like, well, what if other people don't? They don't, trust me. But still, I'd rather take that anxiety away from me. So that goes for anybody on Zoom as well. Email me through Canvas. If there's one of those things on there you want me to work, please. I'm glad to work any of them. Okay, because I want to see you do well. All right. We know what's coming. Okay. All right. Let's jump into today's lesson then. You're gonna need your calculators. So if you have your calculators, go and get them out. And just remember, my calendar is always up to date. I'm always checking it, okay? Be warned, now remember, no class this week, but there is a discussion during your midterm week. Okay, so kind of be aware of that, okay? Been doing really good on discussions, but the grace is done. So on discussions, if I just see, hey, I like that, probably gonna count as a no discussion. Okay, you pretty much didn't, I didn't count, I'm not gonna count you as a reply. No longer will you get the elaborate comment on there. So today, it's back over here where I know you're gonna go see it. Everybody see my numbers okay? You in the back mainly, can y'all see that? Okay, whenever I start working, okay. Good. All right. 5.1, discrete random variables. We need to remember discrete for me, for us right now, not for us, just in general, it means countable, okay? Discrete random variables means countable random variables, okay? You're gonna see this a lot, okay? In statistics, you see it a lot whenever you start reading them a lot more often. Well, what are they? Let me give you a definition. A random variable is a variable whose value is determined by the outcome of a probability experiment, okay? That can seem kind of like, that's a really, really mathy definition. Let me take it one step further real quick and just show you something. You have this right here. I have an uppercase and a lowercase. I have a big X as a random variable and the small x as a specific value of a random variable. Let me show you how you're actually going to see these, okay? So if you'll permit me, I'll just kind of write in between the lines here. How I would write this and how you're going to see it written. Now, mind you, they're saying x, It can be anything. It's a random variable. It's whatever you decide to make that variable. Okay? But you'll usually see it like this. I have to be careful. I grab this pen. There's a button on it. If I grab it just right, I push the button and try to write, and it doesn't do anything. So P obviously means probability. Big X equals little x. Okay? That's how you're going to see it. Okay? The big X is my random variable. Okay? The small x is a value. Now, right now, I get just kind of just walk with me. We're walking down a path. Okay, I haven't got to the lines cage yet, but I'll point them out in a little bit. We'll kind of keep pointing things out. Let me give you an example. Okay, look at it this way. I want to flip. Okay, 3 coins. All of them having what? Heads and tails, heads and tails, heads and tails. Okay, so I'm going to flip 3 coins. Going back in time, we could create a sample space for this. Okay, so I'm going to create a little sample space very quickly. I know that I could get heads, heads, heads. And yes, I have to use those because I'll forget some. And there is my sample space. Can we all agree? Those are all the possible ways I could get heads and tails. So what is the probability, okay, of say getting 3 heads? Okay. Well, if we look at this, notice the probability of getting 3 heads is what? 1 out of what? 8. Exactly. Very good. So watch. This is how you would write this. This is how I'm going to show you this discrete random variable. Okay, the probability, big X, because that's my random variable I'm choosing, equals 3. Because since I'm choosing it to be heads, my random variable I'm classifying as, okay, what is the probability of me getting heads? How many heads? 3. Well, we know the probability of that is, as you said, 1/8. But notice now we're not doing it this way anymore. Because we're using discrete random variables, we're showing all the probabilities now. Okay? So notice I could come in and go, what's the probability of getting 2 heads? Come in here and notice that's 3/8. Once again, we keep making our list, working all the way down very carefully, slowly, and methodically. What's the probability of getting no heads? Obviously, it comes back down to 1/8. Now, this one, it didn't matter. On some, it will, not will. Okay, let me rephrase that. I need to be a little bit more intentional with my saying. I don't simplify fractions when doing this. Okay. There's a reason. Because what do all probabilities have to add up to? 1. Yeah, exactly, 100%. Because look, didn't I give you all the possible outcomes working my way down? I said, hey, what's the probability of getting 3 heads, 2 heads, 1 heads, 0 heads? You could also think of the complement for this. You know, the complement works the same way. What's the probability of getting 3 heads? The same probability as getting 0 tails. Okay, that'd be the complement. But notice all of these equal up to, if you add the numerators, what do you get? 8/8, which equals 1. Does that help you kind of demystify a little bit, just the terminology, just a little bit of the notation that we're using right now? Okay, now mind you, I don't have to use X. You can use whatever you want. It doesn't really matter. We just tend to use X a lot. Okay, you'll see me here in a little bit. I'll use W here in just a little bit. So now's the time for questions. Is everybody good so far? Okay, good. The boat hasn't sank yet. Probability distribution. We think of distributions as things kind of distributing out, okay? Is a table or formula, okay, that gives the probabilities for every value of a random variable X. What you just saw, that P of X equals X. Where notice that P of X equals X is between, no surprise there. Okay, this is just formalizing. Okay, that's all that's happening here. I want you to remember that. This is formalization. It's between 0 and 1 again, right? We're dealing with probabilities. It's always going to be between 0 and 1. This one just says if you add up all of those probabilities, you're going to get 1. That's what that's saying. Remember that little summation notation? What did I just do on the last one? I said 1/8 plus 3/8 plus 3/8 plus 1/8. It's just saying when they sum them all together, they've got to equal 1. Such that the following properties are true. All probabilities are between 0 and 1 inclusive, which means we include the endpoints. That is why that is true. And the sum of all the probabilities is 1. That is why that is true. Okay? You're going to hear that a lot. Okay? Reason being, not in this class, we won't be doing this right here. This is beyond the scope of this class. That would require you to take a calculus class. You can turn these into formulas. Okay, that you can literally just start plugging numbers into, and it's like a little function. Remember what functions do? They take a value, they pop out some other value. Okay, same thing. Us, it's a table. Okay, good on this. Right now, we're discussing discrete, okay? It's very important that we understand that right now we're discussing discrete because here, after midterms, okay, we will be going to continuous random variables. And there is a difference. Discrete, you can tell me, I roll dice. I can tell you what my probability is, right? Very easily. When we get to continuous, it's going to be more like this. Let me give you a hypothetical. I go to El Paso a lot, at least once a month. Okay? The wife and I would go to El Paso, we like it. What is the probability of getting into a wreck, not me, but there being a wreck between the Hobbs city limit and the El Paso city limit? What do you think? I'm just saying a wreck, not me getting a wreck happening between here and there. Pretty much 100%, right? I mean, come on, let's be honest. I mean, look how long that is. There's a lot of wrecks every single day. And when it depends on what you classify as a wreck. Even that we'll just count as a bumper, like somebody hitting a bumper, right? But that's not discrete. Continuous is this. Where have I said this? What is the probability of, we're going to pretend like, here's the distance between here and El Paso. What is the probability of getting into a wreck right there? At this mile marker and so many inches. That's going to go different, isn't it? That's going to be like almost 0. But that's kind of a paradox. How can you have 100% probability and 0% probability in the same area? Okay, whereas it does work. Okay, but notice right now we're discussing discrete, countable, but I want you to kind of get in your head now, so when we get to countable, you already kind of have that seed planted for when we make the shift. Okay, and the shift will happen in, like I said, after midterms. Everybody good so far? I literally don't want to lose you because things are going to get a little abstract this time. Okay, right now we're just proof of concept. Probabilities have to be between 0 and 1. If someone tells you, man, there's a 120% chance that, just think to yourself, that person has no conceptual understanding of probabilities. Okay, and you'll hear it. You hear it a lot. Let's create a discrete probability distribution for X of the rolls of 2 sum dice. I created us a little table. And literally all you're going to do, what would be my little x? Look at what it says. For the sum. Right? Think about it. So my little x has to be what? Remember, we have the P of x is equal to x. This guy doesn't change, right? So what does this guy become? Little x is all become values. Think it's a variable, right? Y'all dealt with this the whole time. in all your math up to this point. Okay, so think about it. That little x is what am I summing to? 2. So right here, you could literally think of this as P of x is equal to 2. We don't write the 2, we're just putting it all into a table. So you could work your way down this value table of 2, 3, 4, 5, 6. Sorry. I say 6, I write 7. I'm getting faster at this thing. 6, 7, 8, 9, 10, 11, and 12. Now, you have to start looking at the probabilities. What is my probability of rolling a 2, or rolling a sum? I apologize. Rolling a sum of 2.
1 out of 36.
Very good. The probability is 1 out of 36. 3 will be 2 out of 36. 3 out of 36. 4 out of 36. 5 out of 36. Notice the 7, 6 out of 36. Then what's going to happen at the 8? It starts reversing on itself. Things start becoming less and less again. So we've got a 5 out of 36, 4 out of 36, 3 out of 36, a 2, and a 1. And all of those should add up to what? 36 over
36.
So the probability of a sum happening is 1. Exactly. That's how that probability distribution worked. Why do we need them? Well, probability distributions are good when you want to see the mass amount of things that could possibly happen. Companies will use them all the time. Okay, I'm planning on going to market with something. I need to know my probabilities as they kind of work out, as this distribution of things happen. Okay, not just dice rolling, obviously, but it can be used in more elaborate terms. Machine learning, AI. This right here is exactly how ChatGPT kind of works on a very low level basis, along with some other probabilities in linear algebra. Is if you write it a prompt, it doesn't know what you wrote. It has no idea what you wrote. It has no mind, even though it says now analyzing, thinking, all that kind of stuff. It's not. It is not thinking. It doesn't know any more what it answered to you than your dog would. Okay? In fact, your dog probably has more cognitive ability than ChatGPT. But it runs off probabilities. It says, hey, this person said this, so what's the probability of the next word being this? After that, this probability being this, the next, and it's a continuous probability distribution that it goes through and back propagates back and forth. It's all probabilities. Okay. And the reason its probabilities are pretty good is why? It's learned, it's watched, it's fed, continuously, and so it's gotten really, really good. You want to see how bad it can get, go back to one of the first version of ChatGPT. You can go back to ChatGPT 1. It's laughable at best in how it worked. It didn't really know how to do like very simple like word problems. Now it's doing complex math and physics. But it's learned. But it's still based off probabilities. Hence the word learning. It's gotten more data. Okay? So, one thing to remember about this, when all probabilities are added, they're going to equal 1. It's also good practice not to simplify fractions when making these tables, okay? Because all you're going to end up having to do is go back and turn them back around because you're going to want to add them together, make sure they equal up to 1. I'm saying that because that might be a midterm question. I don't know. How would you know if this is not a probability distribution? It doesn't add up to 1. Okay, so I may give you a question and I'll ask you all these questions. And it may be like, I don't need to answer these because this isn't a probability distribution. Okay. Now remember, they don't have to be fractions, they can be decimals. Okay. Decimals are great in this class. Okay. Are we good so far? Are you picking up the breadcrumbs of some of the midterm questions? Hopefully I'm throwing out there for you. Okay. The expected value, probably honestly, one of the most underrated Not even gonna read it. My lack of terminology, my lack of vocabulary is very apparent because one, I'm not an English teacher. But I really think above almost every other math, if I could teach everybody in the world this, man, it would be a better place. I love expected value. My friends who try to make bets with me hate that I know expected value. Now, first off, realize, look at what this formula says. It says the expected value for a discrete random variable x is equal, hear my words carefully, equal to the mean of the probability distribution of x. E of x is equal to mu. Why did I just say that? Because when you get questions on your midterm, on your homework, wherever, and it says, hey, some question, yada, 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 here's the mean of this probability distribution. What is the expected value? What are you going to look at? Mu. Whatever mean it's giving you is its expected value. Okay? Simple example, just very quick before I get you into exactly kind of the nuts and bolts of how expected value works. The expected value, okay, let me back up. If I rolled dice, so you can figure this out, and I rolled a 1, and then I roll a 2, and then I roll a 3, and then I roll a 4, and so on to 6, right? How would I find the mean? Math students. How do you find the mean of anything? Add up what? All the numbers, right? 1 plus 2 plus 3 plus 4 plus 5 plus 6. And then divide it by what? Divided by 6. Divided by the number of trials you just did or whatever. It's 3.5. So the mean of a dice roll is 3.5. Conversely, the expected value is 3.5. Why would it be my expected value? It's the mean. Of course it's going to happen the most. Look back. I'm trying to get you to open your mind. Look here. Is it no wonder that in a casino, you probably don't know this, but craps says, hey, when you roll a 7, you lose. Well, why would they say 7? How many ways? Look at that. There is 7 out of 36 ways to get a 7. They're like, well, of course, we want to make sure the probabilities are on our side. And so therefore, what's the expected value of this game? That right there. It's the mean. You have to add all the get the mean, but there you go. There it is, dead center. That kind of make a little bit more sense now because it's the number that's gonna, if you kind of start doing everything, everything's gonna kind of always clump up toward the center. Okay, think about your distribution curve. Okay. So what does that mean? Well, we're gonna play a game. The only one old enough to play with me is her. Everyone else, it's illegal for you to gamble. But me and her, we're totally old enough to gamble, so we're gonna gamble right now. We're gonna play a coin toss game. I want everybody to kind of see how we're gonna play a coin toss game. And we're gonna do it with 2 coins. Okay? 2 coins, we flip it, we know it's simple, okay? We can create a sample space pretty quick out of 2 coins, right? I mean, think about it. My sample space for 2 coins are the probability of getting a head-head, head-tail, or a tail-head, or 2 heads. Good so far? Okay, here's how this is going to work. This is a win-lose game. That's it. It's kind of how betting works, right? I'm either going to win or I'm going to lose. If I win on this game right now, I win $3. Pretty awesome, right? I like that. I like the thought of winning $3. Now, the only way for me to win is I have to get 2 hits. Okay? Otherwise, I lose. Simple enough game, right? That's kind of the lesson in the future. Make sure all the things are kind of worked out beforehand. Make sure you got everything worked out. So I need to know I win when I get head. So what is my probability of winning, okay, with 2 heads? Very good. 1 out of 4. We're all good with it, right? Okay. So notice here. Now, if I lose on this game, you know it's nice? Because she's nice. I opened the door for her this morning. Okay. And she was staring at her phone. I'm throwing her under the bus. I don't care. No. She's going to say, no. I don't like to gamble. So if you win, I'll give you $3. If you lose, don't worry about it. Okay? Pretty sweet game. So now we're going to work this out. We're going to take this and multiply it. Both of them. Okay? Well, notice I need to know the probability. Well, the probability of winning is what? Remember, this is my P of W equals W. That's my win, right? My little small. Okay? So what is my probability of winning? 1 out of 4, exactly. What's my probability of losing? 3 out of 4, exactly. We do the quick math on this. Remember, you can turn 1/4 into 0.25. Do it on your calculator real quick. So here we are. I do the math here, 0.75. I do the math here, that obviously equals to 0. Do all the math to this, and I get a positive 0.75. My expected value of this game, okay? Could I win some? Could I lose some? Obviously, right? If I played the game a lot with her, over time, backwards, forwards, backwards, forwards, backwards, forwards, I'm going to lose some, I'm going to gain some. I'm going to lose some, I'm going to gain some. I know you might think to yourself, well, but when you're losing, you gained, you didn't lose anything. You're right, but I still had to play. And that still affects things a little bit. So my expected value is per game, even when I lose and make 0, I still gained 75 cents. So over time, the gain, the longer I played, over time, I'm gaining 75 cents per time. That kind of makes sense a little bit? Now let's change it. Let's say she didn't like having to pay out, which is kind of the real world, right? Well, same probabilities, but now let's say it this way. We draw a little line here. Same game, win, lose. But now I can win $3, but if I lose, I owe her $1. That sound pretty good? Be honest, would any of you take that right now? If I said that, hey, if you win, I'll give you 3. But if you lose, you owe me $1. It's not 3 and 3. You're gaining 3, but losing 1. Does that sound like a fair deal? Let's see. Is it a fair deal? Win. $2. Why not put $2? Because look here. That right there. Okay, because there's a negative. Okay. Still, using my little table here, probability of that big. Still going to be 1/4, right? Still going to be 3/4. Probabilities haven't changed. I still have a 1/4 chance of winning. There's still a 3/4 chance of losing. Notice what happens here. This turns into what? 0.5. But now look, negative 0.75. And when you add those together, negative 0.25. Your expected value is if you keep playing that game okay, is you're actually gonna lose 25 cents per game over time. So if me and him, every day we played, we said for the next 20 years, I'm gonna play this game. I'm gonna win some. There may be long stretches of me winning. And I was kidding, I didn't mean that, on the lose on this one for that to become two, is it cost me $1 to play every time. It's like going to the fair. It cost me $1. So did I win 3? No, I'm winning 2 because it cost me $1. Now you could work this out as win 3 and then it lose. But does that see how you see how that works now? Over time, it's a losing proposition. Why would I keep doing it? I'm actually bleeding money at 25 cents per game, and that's what's going to happen over the long run. So that's the expected value. And you might be going, I'll never worry about that. Maybe not today sitting in this chair, but do you all want to work forever? I mean, you're going to have to at your age right now for a long, long time. Okay, unless you're going to hit the lottery. But even then, if you don't have a very good sense of money, you're not going to be rich for very long. Most of us have retirement. Well, how do you make money on retirement? Expected value. Is it going to work out for me in the long run? Or am I slowly over time losing money and it doesn't look like, you're like, man, look, I made $30,000 last year in my retirement. Yeah, but that doesn't matter. Look at what's happening in the long term. Hence that law of large numbers. That guy's always running in the background. Okay, so that's what this is saying. When we calculate that long time, what's happening? Are you winning? Are you losing? Are you winning? Are you losing? Okay, and so this shows us that expected value over a period. So far, so good. Okay, let's get in to expected value. You have, hey, just trying to decide between 2 different investment opportunities. Oh, this sounds more real world now. 2 plans are summarized on the table below. The left column for each plan gives the potential earnings, and the right columns give their respective probabilities. Which plan should you use? Okay. Here's how this works. I'm going to work out one of these for you. I'm going to show you how to fill it in. Okay. And then I'm going to show you how you can fill this in on your calculator and have it do it for you. Okay. But as I told students yesterday, and this is no lie, I firmly believe this. To be in this class, you had to at least get through intermediate algebra, which I think if those of you who took it, it's not an easy class. Okay, because most people end up there haven't taken math in a long time. Then most of you took college algebra next. That was no easy class, really. Okay, it can be a little bit difficult. And now you've actually made it into a kind of an upper math class, more abstract. I looked up something the other day, and I'm going to find it so that way I can kind of prove it. Did you know that if you're taking this math class, that you, on average, now mind you, there's swings, of course, to everything. I'm saying on average, that you're mathematically smarter than 98% of the regular population. That means of the average person in the United States, you're 98% more mathematically knowledgeable. Okay, and I don't want to see you lose that by me just showing you everything on your calculator just right away. I want to show you your calculator so you can do it quick and you're not sitting around bogged down with calculations. But I always want to know how the engine works. Does that kind of make sense what I'm saying there? So here's what we're going to do. We got to remember this very, very important thing. We need to know that the probability of e to the x is equal to what? The what?
X.
Someone said it. U. It's always equal to the mean. Okay, e to the x is always equal to the mean. Okay, so we're good there. So I'm going to make a really quick little kind of janky. I'm only going to be working out plan A because I don't want to spend a lot of time showing you something twice. Okay, they work for both. Okay, So I'm gonna come in here, I'm gonna make a little table. In this one, I'm gonna put an X. Here, I'm gonna put my P of X is equal to X. And notice here, I'm gonna have X times that P of X. I have 1, 2, 3, 4, 5 columns here. So 1, 2, 3, 4, and 5. I'm going to copy everything, okay, in this line here. I was trying to draw my iPad just then. And that line there. Okay, literally verbatim, I'm literally just gonna copy them over. Carefully copy them over. 1200, 950, 130, negative 575, negative 1400. And then I do the probabilities 0.1, 0.2, 0.4, 0.1, 0.2. I would work all this out in my calculator. Do 1200 times 10%, we know that's gonna give us 120. I'm giving you all the math right now just for sake of time, okay? But can you see that I'm just saying this X times my probability, okay? A little line here, I take all of these guys here. This X is equal to the mean, which means I summed all those together, right? Because wouldn't that be my average? Okay? So that comes out to $322. That is my expected mean, okay? Oh, sorry, I'm wrong on the math. Give me 1 second. Looking at a wrong number here. You do the math, then you're like, he's wrong. You can catch me wrong on the deal. This adds up to be 2450. When you do plan B and do the exact same thing I just did, okay? So right here, the expected value for plan A is 2450. But the expected value when you do the same thing for plan B is $322. So tell me, if you were painting, which one would you pick? Would you pick plan A or plan B?
Plan B.
Plan B, because your expected value over time is a greater amount of money. So that's the one you would want to look for. Okay? That kind of help you a little bit. Now, this is a very simplified version of finances. Do not go into cryptocurrency or your retirement account trying to do it this way. Okay, there's a lot more that needs to be looked at, like derivatives and stuff like that. But still, this gets you in the door where you kind of have a better understanding. Now, I am sure every single one of you is like, please tell me there's an easier way to do this. Yes, there's a way easier way. I'm going to write it down, and then if you'll permit me, I'll show you how to do it in my calculator, but I won't be able to show you the values and my calculator at the same time. So what I'll do is if you have these values wrote down, I'll be using those same exact values and show you how to put them in the calculator. Okay? So, first off, look here. You're going to have to put, we're going to create some lists. That's going to be your L1 and L2. I'll show you what I'm going to do with the other part. Watch this. If you'll permit me real quick, let me switch over. Okay. First off, we all know how to go to our list function. So go to stat, edit. Make sure there's nothing in it. So in my first list, okay, so I hit my 1200, 950, 130, negative. Please use your, I'm not showing you on here, but use your negative button. Do not use your subtraction key, okay? The negative button is the very bottom button. It should be like the middle, okay? But don't use your subtraction key. Negative, what do we got here? 575. And hit enter, and then negative 1400. Hit enter. Okay, I'm done with that list. move over, use your little arrow key here, go up. Now I'm gonna put back in my probabilities. Before you started this, what should you have probably done? I didn't, but you're better students than me. What should you have probably done?
You sure you got all the numbers incorrect?
That, and she's very right. She's 100%. She actually thought of something I didn't. What else? Shouldn't those probabilities equal up to
One.
1? Make sure your probabilities equal up to 1, okay? These do. I won't be trying to trick you right now, but I want that to be something you kind of keep in the back of your mind, okay? So I've got 0.1, enter, 0.2, enter, 0.4, enter, 0.1, enter, and 0.2, enter. And then I stop, take a breath, maybe look away for a second, and then double check my numbers. Do they all match? Yes, I'm good. Now, here's something neat. Bet you didn't know that you could do this. If you did, congratulations. Scroll over. Okay? Watch what I'm about to do. Watch my hand. You see where I'm highlighted right now? Click up. You see how I just highlighted the L3? Watch what I'm about to do. I'm going to hit the second key right here. When you look at your number 1 key, notice how it has an L1 above it? Everybody see that? L1. Hit my multiplication button. Second key, hit my number 2 button. What just happened? I'm telling it for list 3, I want you to multiply my 2 lists together. What was that?
I don't know if I wrote it wrong or not, but on the second list, the last 2, are they 0.1 and 0.2 or 0.2 and 0.2?
1 and 0.2.
Second.
Could you do that again, the multiply?
I sure can. Come back over here. Let me go up here. Is everybody okay? Do you mind not seeing my screen? I'll show you the buttons. Or if I can, I kind of like zoom out just a little bit here. It's tough. I get it because of the, I don't think what room here. Look here. Do you see how that second key is right here? Look at your L1. There's an L1 key here. So when you hit the shift, there's your L1. And then I can hit the multiply and then hit L2. And all I did was come up here and highlight that area. Good? You see it? Okay, now that's one way. You want to see another way? Some people like that way. I like to give you options. Let me come in here really quick here. Let me hit clear. Okay. Notice I just have an L1 and L2, right? That's all I got. Can we all agree that's all I got right now? Let me go back to my stat key. Go to calculate. We are always going to be using 1 bar stats. You won't be using anything. There is nothing else in this calculation area you're ever going to use in this class. Okay? Come in here, hit calculate. Do you see how list 1 is highlighted? Now notice, you see that frequent list? Hit your shift, that second key. Go to list 2. That's your number 2 key. You see how it has that little L1 there? And then you're going to hit calculate. And look what it gave me for a mean. Isn't that exactly what I was looking for? So all you had to do was just put in that information there. Now it would have done the same thing. Had I done the L3, all I'd have done was say, hey, I want to calculate list 3, and it gave me the same information. Okay. Good. Calculator work, right? It's kind of like one of those things, like you gotta get used to it, okay? Please email me, okay? Like I said, today or tomorrow, depends on when Zoom puts out the deal. I'll put these lectures down. You can go back and kind of like, okay, what did he do? And I'll tell you what I'll do is I'll clip out this section specifically and make sure that's just like it's a little side video that you can go, I don't want to have to try to zoom through YouTube. Let me go straight to right there. I'll put a timestamp on it, okay? You good? So far. Okay. Not too bad, right? I mean, think of it this way. If you've had me in math class before, there's a difference between hard and messy. This isn't hard. It's messy. Let's not conflate the two. Okay, I get messy. Okay. Is everybody good with what I just did? Okay. Am I an email away?
Okay.
Let's continue on. Okay. I don't want to get to a point and all of a sudden have to be like in mid, so that's like I'm being very aware of time today. So we understand what expected value is. Expected value is always the mean, okay? Well, let's look at this. I'm just showing you some formulas. Don't stress. Okay? Good news. You can do this one of two ways. That way, or I'm gonna show you how your calculator does it, okay? But this is the formula. Notice we've got variance and standard deviation. Should make apparent sense that variance is always gonna be with what exponent? Squared. And then to give, but our calculator does not give us variance, does it? Does it? Okay. How do you get variance? Squared, exactly, okay? When you square it, remember, with standard deviation, we always want it to at least 2 decimal places. So let's just say for giggles, your standard deviation is 2.6678. You don't want to go over there and put 2.66 squared. You're gonna get the wrong answer, okay? You always go 1 decimal place past of whatever you're trying to round to. So if I tell you to round to the 100th place, do all your calculations out to the 1000th place, okay? Because especially with exponents, things get exponentially larger, which that means exponentially more wrong very quickly. So go always 1 decimal place past, okay? So if you're getting those wrong answers and you're like, man, I'm getting it. I know I'm getting it right. It's right there. Look at where you're rounding to, okay? I do show grace on the midterm, okay? I'm very nice about those little bit like, oh man, you know, Sabrina here, she's supposed to get 2.66. She put 2.67. You know what? That's 10 points. I get it. Don't worry about it. Because I know she did the right stuff. I am positive of it. There's no way she could have got that had she not done that, okay? It would have been some way wrong number. That kind of help you out a little bit. Does it take the anxiety level like a little bit down a little bit, which is what we want, okay? These formulas help us understand risk, okay? These are what we call risk. But remember this, okay? While these are for risk, remember, this is still what? Exactly, this is still mu. This is what, but this talks about swings. Okay, so. Do I have time to start this next example? I do, but can I give y'all just a hint? Don't write all this down, what I'm about to do. I have it in your notes, but if you start trying to write all this down right now, you're gonna be doing more of this, trying to keep up with me than hearing what I'm gonna do. And because I'm gonna show you once again the long mathy way, and then I'll show you how to do it in your calculator. Okay? Which of these investment plans in the previous example carries more risk? Risk. Plan A or plan B. We're not looking at expected value because think of it this way. Which would you rather make? You're just looking at expected value. I ask you, which would you rather make? The 2450 or the 322? That's all I ask you.
322.
Exactly, same, good answer. Okay. Let me ask you, what would you rather make? The 2450 or the 322? But you have about a 10% chance of losing all your money making 2450, or you have a 90% chance of losing all your money to make the 322.
322.
You still go for the 322? See, but you have a 90% chance of losing all your money. So notice what's the risk difference? There's a greater risk over here. He's betting a lot. He's like, man, I hope. And a lot of people do that. That's why do you think people buy so much cryptocurrency? Okay, there's a great risk. There's safe bets, but people don't like those because I'm gonna get rich when in about 30 years. But it's almost a guaranteed, I'm gonna get rich. That's why a lot of people don't invest in bonds. Bonds, you make home about 2% a year. That's boring. People don't make 2% a year. Whereas you can go bet on Tesla. And you can become a millionaire tomorrow, maybe. I don't know. Does that make sense? But people do it every day. Okay. So let's see how we work out risk here. I got time. Okay. I'm going to end up using my standard deviation. Okay. So look here. I'm going to be using the same form. I'm only going to be working plan A, just so you know. Yes, it gets very, very long. Okay, so I'll do this very as clean as possible because guess what? On my iPad, I can write a lot easier. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4. Let's do one here. I've got my X. I've got my P of X is equal to X. I'm going to have my X times my P of X, which we've already worked out, right? You have to do this part first. You have to no matter what. Let me tell you right now, when calculating risk, you have to do this first part because you have to find out your mean. You need to find your expected value to understand your risk. Okay. So I'll put everything in here really quickly. 1200, 950, 130, negative 575, negative 1400. And then we got 1500. Oops, no. I was looking at the other list. My apologies. Glad I caught it quick, or else I've been like really confabulating. And I'm like, what? Okay. Come in here. I got to put down all my stuff again. I got 120, 190, 52, negative 5750, and then negative 280. I want you to realize what I'm doing is this. I've got to try to find the standard deviation, which is this, the square root of, okay? The sum of all of this is going to be xi minus the mean, which is why we needed to find the mean, squared times my p of x is equal to x. And you have to work out a lot of things. So notice I come in here automatically. I got to figure out this part right here, which is going to be my x minus the mean. Why do I need that? There it is right there. Okay, when I do that, I get 1175.50. Remember, I'm minusing from the mean. Okay. 925.50. 105.50. I promise my writing on your notes that I actually have posted online are a lot easier to read because this pen writes really, really thick. Now I take all those numbers right here, and what am I going to do? What does the formula say? Square them. So that's going to make some pretty really big numbers. So I come in here and I got 1,818,002, 5,856, 5,5,025, 1,113,025. Okay, and let me just kind of speed this along. We're just going to say I kept doing that. Okay, now guess what? I have to take this thing right here, this x minus u squared, and multiply it back to that percentage. Okay, I'm only going to show you the first number, if that's okay with you, because when I do this, I get 138,180.025. I do all that. I'm going to sum all that together. I sum everything. that gives me my variance, which is what your calculator is going to give you. It's going to give you your variance. When I show you how to do this on your calculator, it's going to be your variance that it gives you. Okay, so to find standard deviation, you're going to do what? Oh, sorry, I'm lying to you. I am lying to you right now. I missed it. It's going to give you standard deviation. Now, you don't know which one it's going to ask in the question. If it says variance, you're going to have to square it, right? Okay, but if it says standard deviation, your calculator has already given it to you. Okay, if you calculate it this way, you're going to have to come in there and do all the math yourself. Okay, and kind of just start doing your thing. Notice I get 755. 722.25. To find my standard deviation, I take the square root of both sides, and so the square root of this is 869.32. So, plan A. That was a lot, wasn't it? You imagine having to do that over and over, because you have to do you'd have to do all this again for plan B. Okay? Plan B, when you do it. Standard deviation for it, 863.15. So tell me, which one has less risk, plan A or plan B? Plan B, less swing. The standard deviation, so plan B is great all the way around. First off, think about it. Its expected value is greater at 322, and there's not much, let's be honest, there's not a lot of difference between 869 and 863, but there is less risk. Okay, now let me show you how to do this on your calculator. First off, let me tell you right now, you're gonna have to find the mean like I showed you prior. Okay, do your list 1, do your list 2, and then go back into your calculation, put your list 1, put your list 2. Are you good with that? Okay. Here's how the rest of it's going to work. Okay. In this, watch what I'm going to do. Let me write it down for you so you have it. You're going to have your stat. You're going to go to calculate. Okay. You have your L1 for your list. Frequent, L2, hit calculate. Okay, that gives you your X bar, which is your E to the X. Are you good with that? That's kind of a review of what you just did. Okay, because remember, this is your L1, this is your L2 up there at the top. Now, erase this and kind of pull it back just a little bit so we can kind of have a little more room to write. That out. Okay. Now, I need to put a formula into my L3. I'm changing the way I'm putting my formula in. Okay. Can I get away from this just real quick to show you my calculator? Okay. Can we all agree that I'm using, what am I using here? We use plan A here. We know the plan A was what, 2450, I believe, for the, am I right about that? The plan A was 2450 for the expected value? Expected value was 2450. Okay, you have to have that. Okay. So let me come out over here. Be nice if I could split screen this, but I don't know how they do that. Let's keep that. Okay. Go back over to my stat. Edit, okay. Go up to your L3. Remember how I showed you to highlight that? Okay, this is what you're going to put. Are you with me? You've already got information in your L1. If you notice, this is the same information that I had where? For my plan A. I've checked it, it's good. I then put in the probabilities. I checked it, it's good. Okay? Now, parenthesis. You're just gonna have to kind of copy, look at my little, look right here to see what I'm putting down. Okay, I put a parenthesis. I need to calculate my L1. Okay, so I do L1. Being very careful, minus the mean that we calculated. Remember that 2450? Okay, that expected value, 24.50. I close my parenthesis. Okay? And then I square it. Then I hit multiply. And then I'm multiplying it by what? What do you think? My L2. Hit second, hit L2. And then I hit enter. Okay? That should be very recognizable to you for the first thing I calculated. Okay? Now, here's what I'm going to do. I have to go back to calculate. Okay, so I hit my stat key again. Go to calculate, one of our stats. Remember last time how we used the L2? Well, now I have something in my L3. What am I gonna do? I'm gonna sum it. It's gonna sum everything for me. That's what's gonna happen. And it's gonna sum it using. You do this, get rid of your L2 right here. Make sure to delete that. And we're gonna have to make sure to put everything just from our L3 right there. We're not having to sum things together anymore. Everything's just gonna happen from that L1. Watch what's gonna happen. Enter, enter, enter. Look. That's 755,722.75. That's your number. It gave you the variance. It is not going to give you a standard deviation on this. I'm warning you now. It's not going to explicitly say this is your standard deviation. It's only giving you this. Remember, that's what I got. Look back at what I wrote. That's the number that I'm going to need to take the square root of. Okay, if I want the standard deviation. If it wants variance, there's my guy, right there. Good? Okay. It's some steps in your notes. Okay, let me show you my notes. I'll kind of bring them over here underneath the thing here. And this will be where we'll end today because I don't want to go too far past this. Let me pull the calculator away. I literally show you this in my notes right here. These are online for you right now. Okay, notice I tell you exactly, and notice the handwriting's a lot better. Okay, and it's so much easier on an iPad than you can on screen. But notice, I tell you exactly how to calculate everything. For both of them. Okay, it's more just punch card stuff. Now, I'm gonna be very honest with you. The one that you're gonna see in HOPS, a lot less information. Okay, it's a lot smaller. Okay. But it's still gonna ask for risk. It's still gonna ask for expected value. There is a possible question like this on your midterm. Okay, I don't think you want to spend this list right here. I'm not even gonna lie, guys. That right there takes a while to put down. Okay, and remember, on your midterm, you only have an hour and 15 minutes. So really get good at that calculator use on this one. Okay, this will be something we do now. Just FYI, we won't be using this later on. But it's something you really need to understand now. Okay. Good on this? Feel better? Why don't you practice it, get ahead? Okay, next class, I'm gonna finish up 5-1. There's a few more things I want to hit on this that you will need to know. We'll start 5-2. Is it the next class? No, we're good so far. Start looking over the midterm review, please. Okay, send me emails. Okay. Send me emails, let me know, hey man, will you please work this one? I want to see how it's working. I'll make sure that okay. I will try to work that in order. I'm gonna work these questions in the order in which I received them. Okay, no one will get precedence. Okay, all right, guys, you have a great week.